Hi, viewers. Welcome to another exciting episode of The AI People, where we share inspiring stories of thinkers and builders who are humanizing AI. I'm your host, Vivek, and today I have with me Mike. Mike, why don't you kick us off with an introduction?
Hey there, I'm Mike Murphy. I run content for IBM Research. I've been with IBM for about 5 years now. And I look after everything that we talk about when it comes to IBM Research, all of the cutting edge work we do in AI, quantum computing, semiconductors research, all of that I get to spend every day talking about.
That's awesome. And right now, the theme in the AI world is agentic AI, and it's disrupting every single business process, every possible human endeavor. Science, I think, is one of the highest of human endeavors. And this episode is about agentic AI and science. And I know you've been interacting with a lot of researchers, some of the bright minds who are doing fundamentally, innovative breakthroughs in science. So I want to pick your brain. Like, where do you see agentic AI being applied in scientific research today?
I think there's a ton of places it could be, and it already is, being applied. I think one of the hardest things when it comes to scientific research in general is just how long it takes to get to your hypothesis. Trolling through all of the available data, or even finding the information to be able to start to think about your hypothesis can take weeks or years. It can take your whole career. And so, getting to a place where there are AI structures that can automate all of that away, or large portions of that away, to go actually, having looked through all of the medical history that has ever been published for this problem you're starting to tackle. Uh, the AI system, recommend starting here rather than, what may have already been fertile ground in the past here. Even being able to do something like that could save months or years in a process. And when you then get into actually testing and working through your idea, it can be the process again of speeding up where to start. Let's say you're in material science and you need a chemical that has a certain type set of properties. Let's say there's just for sake of ease, like a million possible combinations of molecules that could get to that end goal you're looking for. That's far too many to start with, to start thinking through and trying to go, okay, does this one work? Let me test it. Building systems that can narrow that down to 1,000 promising ones, and then 100 really promising ones, and maybe 10 to actually move into the experimental phase in that case and actually start putting together that that could be a decade's worth of work that gets shrunk into weeks or days depending on the system. And we're already starting to see systems like that being built.
That's really good. You bring up a really good point, Mike. Um, the real value is in the applications, right? The sooner you can get to applications, do the field work, see if, let's say, in the case of material sciences, material makes sense for this application. Um, that that's really where the value is. Instead of spending all those research cycles figuring out the right combination of material, formulating a hypothesis to be able to do the experiments. But again, question to you: do you think agentic AI is a mature phase at this point in time where we can really trust these systems to formulate the right hypothesis to be able to make the right combination before you can embark on research?
I think it's probably too early for systems to create hypotheses for us, but there are absolutely systems that can get us to start thinking about the right way to move forward much, much faster. I don't know how many scientists out there right now would want to maybe get straight to the automated hypotheses part. But at the same time, you could have an inordinate amount of data that's come to you for, let's say, materials science again. You've got, you know, every possible chemical combination that's ever been found in the world. Um, there are already systems. There's one that IBM Research has been worked on called AI Hilbert, where it's like, feed all that data in. What can I look for that I haven't looked for before? Asking the questions for you is like a new thing that's being automated, which I find quite cool.
That's great. And how is the scientific community responding? Are they responding positively? I know there are a lot of like AI scientists
Mm,
applications out there which can co-pilot,
mm.
research with you. I've interacted with some students in Stanford University, for example. I'm in the Bay Area, and they seem to be excited about it. But how is the industry research community um, warming up to the idea of using co-pilots for research?
I think that the biggest gain right now and the biggest positive thing we're seeing is being able to standardize the way that you can do experiments. In the past, let's say you at your research facility in Switzerland came up with this like really neat way to process your information, like some thing you hand coded, you and your team put together to find your solution. And you put it in a paper, and then that workflow is gone. Like it's just in your file somewhere. It's not available on GitHub for anyone. And so someone else in France comes along, or maybe somewhere farther away, because it probably could be right there. Comes along, wants to tackle a very similar problem. They're probably starting from scratch just on the workflows, even though someone else probably did it already or did something very similar. And so getting to a place where those workflows can be standardized, put in the open source community, we're starting to see that. And that is super exciting for scientists because a lot of their time isn't necessarily spent doing the hard science, like sitting there doing experiments. A lot of it is spent cleaning data, building pipelines so that they can like test things, and then hopefully being able to allocate time to actually run those tests. But if you can standardize all of those with experiments that you can find online, and then some kind of agentic structure so that you can just go, hello machine, here's my data, here's what I need done to it, get back to me when you're done. And then you can go start thinking about something else in that meantime. That is super exciting. And we're starting to see that become a reality.
So I do see the benefits in terms of productivity, and the mundane tasks of research can be done by agents so that the researchers can focus on the exciting stuff. But what risks do these agentic systems introduce? For example, human capital, IP, that research is all about that.
Mm.
And do these systems, create risks when it comes to those spheres?
I mean, I think a lot of what we're seeing in AI right now, there are inherent risks in all new experimental technologies. But the scientific community, for the most part, especially compared to maybe some other fields, is such a grounded field, like so grounded in the rigor of itself, the scientific method, peer reviews, being able to show your work, that things that are coming out have guardrails put in place. So, for example, everything we do at IBM Research, we have a very strong safety and responsibility team that thinks about these exact questions before we release anything. Like all of our Granite models have been indemnified on Watson X, or all of the guardrail tools that we have built into Granite. That has all come out of IBM Research, and so it's the same for science. It's like anything we're working on that is at the forefront of our minds. I think for the scientific community in general, I don't want to speak for all scientists ever, but like I think a lot of them are thinking that way. And so, it's less about creating something that could, you wouldn't build something to then just let it run and then it's out for the world. It's not like the system is going to publish the paper and then, some other systems are going to peer review it. I think for the very, very long future, there's going to be enough humans in the loop to go, that's wrong, or I need to refocus you, like that's what would probably happen now. The guardrails, there are things in the systems themselves, but there's also still the human to go like, okay, that was a tangent. I see why you did that, but let's focus back this way now.
It's great. And one of the seismic shifts that we are seeing right now is hyper automation when it comes to software. Like you can literally create software instantly, right, in these days, and the cost of intelligence is tending to zero. So where do we as humans, focus on? Do you think the foundational scientific work in physics, chemistry, biology, that's gonna become more important? And I know you work with a lot of leaders who are, pioneering research in those areas. So can you maybe comment on like what exactly do you think will be important areas to focus on?
It's hard to truly automate creativity or curiosity. You can create systems today that are astoundingly good at finding the signal in the noise, or working through insanely large data sets to get to insights that a team of scientists couldn't work on their whole lives. But there's something intrinsically human about scientific discovery. It's like our, with rigor, but it's like our understanding of the world. And, until we can get to the point where we're building systems that have eyes, ears, nose, heart, like I don't know if it'll be exactly the same. And this might be a dorky tangent, but I've been watching a lot of old Star Trek recently in a post scarcity society where automation is everywhere and can do everything for them, including you know travel faster than the speed of light. There's still scientists. There's only a few roles in Starfleet. One of them is scientist. I think that shows you there will always be new things to uncover, and these tools will just help us do it quicker.
Great. And do you think agentic AI is probably the death of creativity, but the birth of true imagination?
I don't know if it's the death of creativity. I think it's the death of being able to be bored. Like you can always, you talk to these systems and get it to create an app that does whatever you want immediately, or write you something, or engage with you. But that inspiration is still gonna, require, for the most part, you can use these things as interlocutors really well. I've definitely done that even in my own not very scientific work, is, bounce things off of things. But there's just a difference, I think, in the way that you would do that with someone with lived experience versus a computer program that has a ton of knowledge, but maybe not the lens through which to view it.
Great. And where do you see the ethical dilemma in terms of using agentic systems for innovation?
Mhm.
We cannot completely understand what kind of data went into training these models.
Mhm.
When we are co-innovating with agentic systems, how is the scientific community approaching it, especially in their line of work? This is like uh, a pretty sensitive area to navigate. So
Mhm. I mean, it depends on the field. I think the way that these tools would be integrated into medical research would be very different than something software based. Someone working on a new automation tool would probably be more readily, interested in diving into the cutting edge, whereas someone that needs to deal with HIPAA compliance, or GDPR or something like that, there's there's going to be systems that are in place. There already are for a lot of the tools that we're using, that ensure that there isn't these kind of like ethical quandaries, like, you're not creating some kind of trolley problem the second you press go on this system. But I think, there's the ability to do things faster, and maybe find new things that we couldn't before. Yes, I mean, there's always the fear that you could use a system that is designed for finding new molecules to find a new weapon or something like that. Something that, but that's really true of any technology. You could say that about cloud software, or steel working. Like, any advance in society is going to have that possibility, and that is a global ethical quandary that we as a species have to deal with, and we continue to deal with in every given day, I feel like, these days.
great. And Mike, I know we talked a lot about agentic AI for scientific discovery, uh, but I think it's also worthwhile to talk about scientific innovation, the processes for bringing innovation into agentic AI. And I know IBM does a lot of work, especially in open source. So do you want to like comment on that?
Yeah, we do a ton. I mean, as much as we, or anyone is using AI to discover the future, we obviously are working on the future of AI every day. And we do a ton with the open source community. I think our last two research directors have both made it very clear that they believe the future of AI is open, and the way to compete is, kind of level playing fields on the models and building your systems on top of that. And we work closely with all of the big players. I was just working on a story with some researchers about our roadmap with PyTorch, and it's like there's so many pieces of the stack that you can still upgrade. The cost to train a new model is still massively high, but the cost of storing data for AI, the cost of inference, even all of these things can still be brought down. And that's a lot of the work that we at Idea of Research do, is, you know, how do we turn these AI systems into enterprise ready tools that a multinational corporation can just run with? It's great that we as consumers can use these tools in our daily lives, but how do you operationalize them for, 10,000 customer success employees or like 5,000 HR reps or something like that? And so there's a lot of work at like scaling that I find really interesting and we focus on.
That's great. It seems like there's a lot of good ways we can bring agentic AI into scientific discovery, and with the scientific innovation, we can further propel the progress that we have with agentic AI. What advice would you give to researchers who are toying with the idea of using AI agents, AI scientists in their respective fields?
I think leaning on the community at large, both your scientific community and then the AI community at large, to say that you're doing these. Obviously, I'm biased as a communicator, but I think everyone should be communicating all the time. And the more you can, obviously you're trying to probably do something proprietary, but the more you can talk about what you're doing and say, I have created this pipeline to do X, I think it would be really valuable. Or how do I make this more valuable for more people? And getting that constant feedback online, you're only going to create better tools, not just for yourself, but for the wider community.
That's great. Well, thank you so much, Mike. It was a pleasure chatting with you today as part of the AI people. Uh, Look forward to having a more detailed conversation around agentic AI and science. Maybe we'll do another episode at the Octown Heights where we have the IBM Research Lab.
Be pretty awesome. Thanks for having me.
Great. Thank you.